just give the time to week 9. Then you will have some 3-4 days to prepare for quiz 2. Okay. Okay. So people who have joined just now, open a new tab and type joinpd.com, and in that type this code JTLONB, and yeah, even here also you can see it on top right. So without further delay, so week 9, see till week 8 you might have understood what are samples, how do we sample, how do we get samples out of a distribution, and what are different kinds of distributions. So from those distributions, how do we sample? And then we have studied few theorems like central limit theorem and weak law of large numbers. So these theorems and weak law of large numbers will help us. Maybe weak law of large numbers will help us to bound the probabilities, and central limit theorem, on the other hand, central limit theorem will help us to approximate the probabilities. So whatever the distribution is, you don't need to worry. So collect some samples out of those distributions, enough number of samples out of those distributions, and by considering these samples itself, we can actually compute few probabilities, approximate few probabilities by converting that particular distribution to standard norm. And in week 9, what we do is, so till week 8, it is not a real life scenario where you know the distribution and then compute the probabilities. This is not going to happen in real life. In real life, when you see the data, you will not directly know that from which distribution is it coming from, or what kind of distribution I can fit it. So usually what happens is you don't know the parameters of your distribution. So likewise in binomial or Bernoulli, till now whatever distributions you have seen, every distribution has some parameters. For Bernoulli, it has some P, probability of success is the parameter. And you don't, in real life, you don't know that parameter exactly without simulating few samples out of the distribution. So likewise, binomial has N and P. So the number of trials as well as the probability of success. Poisson has rate lambda, and normal has a mean mu and variance sigma square. So these are all parameters of each and every distribution. And in real life, you don't know what is this particular parameter is, right? So for that, what we do is we estimate the parameter. So that is what week 9 you might have learned. Week 9 is all about parameter estimation. So if I know some samples, using those samples or extracting few samples out of the distribution, using those samples, can I estimate my parameter? Whether it
So in this case, you assume a distribution, is it?
Yeah, so
Or
in
you
this,
don't
yeah,
assume
in
distribution?
week 9, yeah, we assume the distribution. So it's like we are assuming that, okay, this data is coming from Poisson, but I don't know the rate of or the parameter of that Poisson.
Okay.
And then what we do is we extract few samples, and looking at the samples, doing some computations, we try to predict the parameter. And usually what happens is 60, not even 60, even 70 to 80% of the data you see, you can easily guess the distribution. So you know the real life examples of each and every each and every distribution, right? Usually, so if I am tossing a coin, definitely I know that particular experiment will fall under my Bernoulli case. It will not fall into any other distributions. Or if I am continuously tossing a coin n times, and if I am looking at the success, I know this experiment fall into the case of binomial. And also the waiting time for a cab to arrive at some location. So I know the waiting time will follow Poisson. So these kind of situations, or most of the situations by now, till now, is stabilized. So most of the data we have enough number of library to look into and guess the distribution, but we cannot directly guess the parameter of the distribution. So for that we are going to estimate the parameter, best estimation we can do. So we cannot exactly predict this is what the parameter value is. We cannot do that, but whatever methods we follow, it will give us the best parameter estimation. So likewise in week 9 we have seen two methods, two ways. One is called methods of method of moments estimator, and the other one is maximum likelihood estimate. So one is MME and other one is called ML. So these are two kinds of estimators. In week 10 you will see the other estimator, which is Bayesian estimator. So these are different methods to get the parameter, to estimate the parameter. Okay, so yeah, and again before going into parameter estimations and all these things, as this is a parameter and we don't know the parameter. So here in week 9 parameter is unknown. We know only the samples x1 to xn, and now what we do is we estimate the parameter, which is the function of the samples. And this particular parameter, whatever the estimator is there, parameter estimator is there, that should be a good parameter estimator. It should not be like a bad one. You shouldn't come up with a function of the samples that will be used for parameter estimator, which estimates the original parameter. Should not be too vague or should not be too bad. So for example, if I have some n samples, you shouldn't stick with only one sample. Parameter p hat shouldn't be like x1. So there are some better parameter estimators other than this. How do we judge this in between? How do we judge between x1 and the other parameter is by computing, again, few things we have which are called as bias. Bias is a some computation between expected value of this parameter estimation minus the parameter. So it will give us the error. So usually we are worried about error. How much error is going to come if I estimate my parameter as like this, and there is risk, there is variance of this parameter estimator. So in the lectures you might have seen, and the open session also, Prashant might have explained you all this stuff. So there, the parameter estimator should be a good estimator, and then using these methods, we estimate the parameter. Okay, so let us solve few problems, and if required, we will discuss few concepts around that also. So here we have x1 to xn be the IID samples from a distribution x. So now I have a distribution x, and I have drawn some n samples out of that distribution x, and this x has some mean mu and the standard deviation sigma, and we let some mu hat, which is an estimator of mu, is equal to 20 times the sample mean. So why we did 20 times is even I don't know. So we just wanted to design a problem. So we just gave you like 20 times the sample mean, which is x1 plus x2 to xn divided by n. So we let this be an estimator of mu. So what we asked you is find the risk of mu hat. So what is the risk in other terms? Or usually what risk is called?
Mean square.
Mean square error it is.
Mean square error. So which is also called as second moment of error. So the first moment of error is bias, and this risk is the second moment of error. Okay, so this is mean square error, I hope everyone knows the formula for finding risk. Yes, no, are there anyone who joined the session but unable to get this?
No, I just joined the session to listen to you, sir.
Okay,
I have not gone through the uh,
lectures, is it?
lectures. Just want to listen so that you'll give me some idea, and based on that, I thought of doing the graded.
Okay. Okay, so let me give you the idea behind, or the maybe formula. I can give you the direct formula for this risk. Try to use that formula. Uh, risk risk is a function of this mu hat and mu. Okay, and it is equal to expectation of. Do I have to write it somewhere? This.
It will be better, sir.
Okay, just give me a second. Okay, I thought this is a solve with us, and I don't need to write anything. So I have to connect my Wacom.
No, last 2, 3 solve with us.
Yeah, yeah.
You are writing only, sir. So I think next solvent with us, you have to
I will be ready.
writing.
Yeah, yeah, I should be ready with writing also. Okay, just hold on. Okay, the others who know the formula, just compute. So you can use the direct formula, or you can write risk in terms of bias and variance. So you can also use that also. Okay, I'm just stopping this. Okay, so risk. So risk we compute for the parameter estimator, and this risk is called mean squared error. So you can see from the name itself, mean squared error. So we find the error. Error is basically theta hat minus. So if I say theta is the parameter, am I audible? Right? Okay.
Yes, sir.
Okay. So theta is the parameter, and theta hat, let theta hat be a estimator. Theta hat is estimator of theta. Okay. So mean square error, squared error. So error is basically the difference between these two, estimator and the parameter, and then we square it, and the mean is basically the expected value of this. So this is called risk, and this is how we denote it. Okay. So this is what risk is, and we also have bias. Bias is also, we use it for parameter estimator. So bias is basically the mean of this estimator minus the estimator. So mean of the error basically. So you see this is what it is. Error is theta hat minus theta. So the mean of error is what bias means. So theta is independent, is a constant parameter we know. So it will go outside and then this will be expectation of theta hat minus theta. So observe here in week 9 theta hat will be a random variable. Theta is a constant. Okay, so the parameter is constant, unknown constant. Theta is unknown constant, and this theta hat is a function of the samples, and we know these samples are random variables. So theta hat is basically a function of random variables and random variables. So this theta hat will be a random variable. So once it is a random variable, it has some expectation, it has some PMF and some CDF. So PDF. If it is continuous, it is PDF or CDF. Okay. So don't confuse with theta and theta hat. Theta is unknown constant. So it's a constant, but we don't know. So we are trying to predict or estimate that particular theta. But theta hat is a function of random variable. So theta hat is a random variable. So it will have some expectation. So that is why we have expectation of theta hat, because it is a random variable. But expectation of theta, so as theta is constant, expectation of theta will be theta only. So you can use this bias, and we also have variance. So variance of theta hat, which is usual variance, variance of error. So right, variance of it is basically theta hat minus theta again, but again this is a constant. Adding or subtracting a constant within variance will not affect much. So this will be variance of theta hat only. Yeah, YouTube link. Just a second. Oh. So considering these three things, there is a good connection between these three, so which is called as bias variance trade-off, I guess. Yeah, so that should be it. The risk, you can write it in terms of bias and variance. So bias whole square plus variance. Okay. So now we asked you to compute risk. So you can compute bias and variance and square the bias plus variance, or using this formula, just what is theta hat, what is theta. Even though you expand it, you will reach this thing only. Okay. So has anyone tried this out? Preparing for quiz 2, right?
Not it.
Try to prove. It's easy. Just expand this square and separate the terms. You will get it. You will get this. So this is also a good exercise to try it out. Okay. So 10 people responded. So I again have a question on bias and risk. So I will give more time there. But as of now, we will just try to understand how to solve this kind of problems. Okay, let me see what all. Okay. 6 people gave option C, and 4 people gave option A. The difference you got is whether it will be 400 mu square or whether it will be 361 mu square. Okay, let's see. So the solution will be in terms of computing bias, variance, and finally squaring the bias and adding the variance to it will give us the risk. So in order to compute bias, we need expectation of mu hat, right? So bias is basically expectation of mu hat minus mu. So if I have to compute expectation of mu hat, what it will be, mu hat is given to be 20 times x1 plus x2 to xn divided by n. So now using the linearity of expectation and constant pulling out, so what you can do is 20 will come out, and now what happens is expectation of x1, okay, n also you can pull out, n is also a constant value. So now it will be expectation of x1 plus expectation of x2 plus expectation of x3 and so on, expectation of xn. As you know that this x1, x2 to xn are samples coming from the distribution x which has mean mu. So therefore expectation of x1 will be equal to mu, expectation of x2 will also be equal to mu. So likewise expectation of xn will also be equal to mu. So finally it will be mu plus and so on till mu. There will be n mu's. So that will sum up to n mu. So we have 20 by n outside. So 20 by n into n mu, and then n will get cancelled and we are going to get 20 mu, which is expectation of mu hat. So we are not done yet. So in order to compute bias, what we have, bias is equal to expectation of mu hat minus mu we have. So expectation of mu hat is 20 mu minus mu, you are going to get 19 mu as bias. Okay. So once you get bias, you have to square the bias. So if you square it, you are going to get 361 mu square. Okay. So yeah, this is halfway through. We are halfway through. We computed bias. So we are yet to compute variance. So how do we compute variance? So variance of mu hat I have to compute. So mu hat again is given to be 20 times x1 plus x2 and so on xn by n. Again using the properties of variance. So you pull out the constant value which is 20 by n. So once you pull out square times variance of x1 plus x2 plus x and so on xn. So now this is sum, and also you know x1, x2 to xn are independent to each other. So it is given in the question only. So now now we can split the variance. So we can write it as variance of x1 plus variance of x2 and so on variance of xn, because x1 to xn are independent to each other. So we can write it. This is a property of variance. So now variance of x1. Again, x1 is a sample coming out from the distribution x which has variance sigma square. This is also given in the question only. So now it will be sigma square plus sigma square plus sigma square and so on, sigma square n times. That will sum up to n sigma square. So n and n will get cancelled. Denominator we will have n. So the variance of mu hat will be 400 sigma square by n. Now finally what I have to do? I have to square my bias plus variance of this mu hat will give me the risk. Therefore the risk will be equal to 19 mu, which is bias square, it will be squared plus 400 sigma square by n. Finally it will be 361 mu square plus 400 sigma square by n. So it will be option C, not option A. So most of you have given, those who have given option A, you might have missed out that minus mu while you are computing bias. Okay. 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 So this is how you can compute risk. Okay. Let us solve the important problems in week 9, which are estimating the parameter using some standard methods. And out of those two, If you ask my favorite is maximum likelihood. Okay, so so let's see how we can solve problems on parameter estimations using this maximum likelihoods and methods of moments estimate. So this is the setup we have. So let x1 to xn follow IID x. So I told you this in week 7. This IID, or in week 2, I stress this, IID will come like it's a routine thing. So you should be, by now you should know what is IID. So there are some x1 to xn IID samples coming from x, and x is a random variable with the density function given to be like this. So theta by x power theta plus 1 when x is greater than 1 and 0 otherwise. Okay. So as we said, it is density function. If you integrate it from 1 to infinite, you will get 1 irrespective of what theta is. Okay, independent of what theta is. Now, so we know the density function. That means you know the distribution, but you don't know the parameter theta. So here, the random variable x has a parameter theta inside it. And now what we did, we have taken some samples from this distribution. So some 6 samples we have taken, and the samples look like this: 3, 6, 2, 7, 8, 10. So now by looking at these samples, 6 samples, we are going to estimate theta using maximum likelihood method. Okay. So those who know maximum likelihood estimate method, you just try to solve it. How many of you know? Just hand raises. Okay, 1, 2, 3, 3. Mohan Raj, Ritvik, Abhishek. You people don't
Went
know.
through the lecture, but cannot say,
Okay.
Sir, I remembered it like on Sunday, like after the open session, but then I forgot again.
Okay. Yeah, I can see some other
Like
people.
lot of data to process with Python, Stats 2 and Maths 2 together.
Okay. Okay. Yash Agarwal, Swarnali. Okay. Okay. Those who know, Deepa Agarwal.
Yes, sir.
She used log or
You
something.
yeah. You haven't gone through week 9 lectures, is it?
No, sir, I have gone through. I did.
You know this then?
Yes, sir, I know.
Okay. Okay. Good. So people who know, just write out. People who don't know, I will just explain what maximum likelihood estimate in maybe in 5 minutes. Try to get within that 5 minutes. Okay. So let people who know at least please make a note of this question. Please note down this question so that I will stop this screen and I will just go back to my journal screen.
Sir, anyhow in join PD that web there it is available now. Sir, the
Yeah. In join PD it is available, right? Okay.
Yeah.
Good. Okay, then I will just stop the streaming. I will just go to my journal screen. Okay. So what this maximum likelihood estimate is? So likelihood function. So what does this mean? Like what does mean is likelihood. So likelihood means how likely this particular sample can occur. Okay. So if I have samples, just like in the above case, 2, 3, 2, some 10, 6, 5, from the distribution, what is the probability or what is the likeliness of getting 3 in the first distribution, first sample, getting 3 in the first sample, then getting 2 in the second sample, then getting 10 in the third sample. So this is like counting or multiplying or events happening continuously or simultaneously. So I need to have 3 at the same time. I need to have 2 in the second sample. So it's like intersection event. So I need to have 3 in first draw or first sample. Along with 3 in the first sample, I need to have 2 in second. So like this. So I need to have 5 in fifth sample. So intersection means what in probability? What we have to do?
Multiply.
Multiply. Correct? So if it is continuous case, instead of probabilities, what we will use?
F of x.
Yeah, probability density functions, right?
Fx. Yes, probability would.
So that is what this likelihood means. So likelihood is basically fx of 3 times fx of 2 times fx of 10. So this will give me, so this is the density function, value of the density function corresponding to the value 3. So that means in the first sample, I'm going to get 3. So this is the density to get sample 3 from the first sample. Along with this, getting 2 in the second sample is multiplied by fx of 2, multiplied by fx of 10, multiplied by fx of 6, multiplied by fx of 5. So collectively, this is how we write. I is equals to 1 to 5. How many samples are there? Fx of, so pi represents the product. So just like summation, this symbol, this represents sum and this pi represents the product. Okay. So fx of xi's. Okay. So if I have 5 samples, now each of the xi's are, this is x1, this is x2, x3, x4 and this is x5. So this is likelihood function is a function of the samplings. So where you observe, now this is no longer a set of sample. So you have observed what samples you got. So this is called sampling. So this is one sampling. And your likelihood is a function of this sampling. So this likelihood function depends on this x's, small x's. So we will write likelihood function as x1. So if there are some n samples you have drawn, so likelihood is a function of these n samples, which is product of these fx's. Okay. And this function will give us in terms of parameter. Because in your density function, there will be a parameter theta or alpha or whatever it is. Let I am assuming it as theta. So now it is a product, and in place of small x, you no longer have small x, you will have some xi's. But in place of theta or the parameter, unknown parameter, you will have parameter only, the theta only. And this will turn out to be a function of theta finally. So once you substitute x1, x2, x3 to xn values, okay, I need to write this thing also. So it's not only function of x1 to xn, it will also be function of, so if it has one parameter, it will be a function of that parameter. Or if the given distribution has some 2 or 3 parameters involved, theta 1, theta 2, theta 3, then my likelihood will depend on theta 1, theta 2, theta 3 as well. But as of now, for simplicity, I am assuming my distribution has only one parameter. So this likelihood will be a function of the samplings as well as the parameter theta. Okay, so I got my likelihood function. But in order to predict, so if for suppose I got after substituting L of theta has something like 2 theta by 4 theta plus 1, something like this. So how should I guess the parameter? So what should I say? Theta is this, or theta is 0, or theta is 1, or theta is half. What is the best estimator? For that,
We should.
we use some calculus part here. So why we use is because we need some value theta for which this particular L theta, so this likelihood function, will be maximum. So why we are looking for maximum is a question to think. So why we are behind maximizing this likelihood? So what I said is, okay, let me repeat. So now L theta, so L likelihood, whatever the likelihood is a function of theta now, and you have this function now. How do you guess what is the value of theta? So which is the best value for theta? And it turns out that best value will be the maximum. So whatever the value that maximizes this L theta is the best value. And my question is, why we are going after maximum?
Because we want to make this, whatever the sequence that we have, we want to make the probability of getting that sequence to be maximum.
Correct, exactly. So why we are maximizing is because, so you see, this theta can take any value within that particular range. It can take any value out of all the possible values. For which parameter value this particular likelihood function or the likelihood sample series we have in our example, this 3, 2, 10, 6, 5 has high probability to occur, because we observed that thing, right? We observed 3, 2, 10, 6, 5. So that means if we draw samples, we are getting 3, 2, 10, 6, 5. That means for which value of P, getting this particular sequence has high chance. So that is why we are going after maximizing. So how do we maximize? How do we
So
get the maximum?
what did you say with terms of the value that like
Which
when
value?
the samples you said?
So this L theta, so this likelihood is a function, is a product of densities of the samples, right? Right?
Yes.
So and also this likelihood is nothing but it gives us the density value such that the sequence is 3, 2, 10, 6, 5.
Okay.
Right?
Hmm.
So we are going after that particular parameter value which gives me high density, high L theta. So high L x1, x2 to x5, so that this sequence is highly probable to occur.
Okay.
This has occurred, right? This 3, 2, 10, 6, 5 has occurred. You have observed it.
So when we are looking at likelihood, we are looking in terms of the particular sampling which has been given to us.
Yes.
And and because we already are working on a particular sampling, we are only considering the theta parameter when we are doing the final calculation.
Right. So right now you have only that sampling with you. And we try to maximize that samplings occurrence. Okay.
Yes, sir.
So how do we maximize it? Any function given to you, how do you find the maximum value of that function?
Will differentiate it and equal to 0.
Right. So you differentiate and equate it to 0. So what we do is we differentiate this L theta with respect to theta and equate it to 0. So this is the next steps, calculus steps. So you equate it to 0, you will get some theta is equal to theta star, you represent it. So theta star, you are going to get something, and this theta star is the best estimator for theta, and this theta star is called as ML estimator. So why we call it as ML estimator? Because we have used that likelihood function in order to estimate our parameter. Okay, this is one way to estimate. So this is one method. So this method is called maximum likelihood method. Okay, so this method is called maximum likelihood method, where we find the likelihood function and then we find the parameter value for which this particular likelihood function is maximum. Okay, so now using this small concept, let us go back to my solve with the slides. And yeah, so why we do log is for simplifying. For derivatives, taking derivatives will be easier to when you take log. Okay, so yeah, without log also you can derivate it if you are good at calculus, but taking log will help you for simpler calculations. Calculation purposes, it will be helpful. Okay, yeah, now using whatever just now we discussed, use those stuff and try to get at least get through halfway. So slowly, see, these are the steps you have to follow. Slowly write down the function, likelihood function, using this 3, 6, 2, 7, 8, 10. So write down the likelihood function in terms of theta. Okay. So how do you write it? See, here you have small x as well as theta. So now you will not have small x because you can substitute 3, 6, 2, 7, 8, 10 within the likelihood function. And you will only have your likelihood function in terms of theta only. Then you differentiate it, equate it to 0. You will get the estimator value. Usually we do ln, log to the base e. Yeah. So if you have used log to the base e, then you don't have the other term. When you differentiate, you will not have any log from 10 base e or something. So you can avoid those constants. Yeah, so Prashant, according to the question, we will not suggest you to take log or something. So usually, yeah, here you see, better take log to the base e, because when you differentiate it, you will not have a constant. See, if you are taking some log to the base 10, log to the base 10, if you differentiate, you are going to have a constant which is log 10 to the base e again. Okay. So in order to exclude, so usually in this particular course, you just use ln. Most of the times ln will help you out. And also, as I said, this taking log is just for simplification purpose, because maximizing L is same as maximizing log L. So if L is your likelihood function, because log is an increasing function. So from there you can easily observe, if x increases, log x also will increase. So whatever the properties x has, the maximum value of x will give us at the same place. So this log x will also take the maximum value. So that is why, for simplification purposes, we take log. Or else, if you are okay with differentiating directly, do direct differentiation. Okay. So what happened to this particular question? Okay, tell me, at least people wrote the likelihood function.
Yes, sir.
No.
Yes, sir. Yes, sir.
Have you got your likelihood function in terms of theta only? Only in
Yes.
terms of theta?
Yes, sir.
Okay. There many of you got stuck, is it?
Yeah, after that, I did not know how to go.
How to differentiate?
Yes, sir.
Okay. So, okay, maybe in this particular example, you will know what is the advantage or benefit of taking log for your likelihood function. Okay. So let us dive into the solution. Okay. Many of you are getting 1.39, 0.5, 0.6, 0.6 also. 0.60. Okay. So within the 8 submissions only, I got some 3 people saying 1.39 and 3 other are saying 0.6. Okay, let us see.
And another cheat is that whatever answer we get, if we substitute and take an integral from 1 to infinity, it should be giving 1. Like
But
whatever
the thing
value.
is, whatever the value theta you put for here, you put here, if you integrate it, you will be getting
It will
1
be
only.
Okay.
Okay. Or else if we have given you like that, you will simply integrate it and find the value of theta, right?
I didn't get that.
See, if 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 there is only one theta which satisfies the integral 1 to infinite, this particular fxx will give 1. What I will do is, instead of doing all these things, I will simply integrate, na?
Okay. I understand.
Integrate and get the value theta. But for any value theta, you are going to get the integral 1 to infinite as 1 only.
And that will be for every function, right?
Usually that will be for every function. That is why they are called parameters, right?
Yeah. Okay. It is free to take any value.
It is free to take any value.
Okay.
So okay, let us go step by step. Let us write theta value first. Sorry, likelihood function first. So likelihood function, as I said, we can write it as product of the densities. So once you write the product of densities, so here they have taken x1 to xn only, but you don't worry, at last they will substitute x1 and xn. Even though you substitute at the start, it's fine. It's not a mistake at all. Okay. But here they will treat those x1 to xn as constants, which are independent of theta. Okay. So what they have did is, they have simply taken the product. So the product will be like this. So theta by, if it is x1 or 3, so whatever it is, it will be x1 to the power theta plus 1 will be the first value, times theta by x2 to the power theta plus 1 times theta by, like this, and it will go till 1 by xn power theta plus 1, and sorry, theta by xn power theta plus 1. If I take theta's, the numerator theta's product, it will give me theta power n. So here, so I am at here. So theta power n times 1 by x1 power theta plus 1, x2 power theta plus 1, and so on. So this will be your likelihood function. So integrating this is differentiating this, you have to use u by v formula, where you have to use v times u dash minus u times v dash divided by v square, and then equate it to 0, then getting the value theta will be a bit painful or complicated. Rather, what we do is, we take log of this likelihood function. So if I take log on both sides, what will I get? Log helping, where log helps you is, so if I take log on both sides, on the right hand side, what happens is, log a by b, you can simply write it as log a minus log b. You no longer have something like numerator divided by denominator. Okay, you will have log theta power n to the base e. So now theta log a to the power b to the base e, you can write it as b times log a. So here you can write log theta power n as n log theta. Now the denominator will go to the minus of log side. So this will be minus. So the denominator, if you observe, it is x1 times x2 times xn whole to the power theta plus 1. Now the theta plus 1 comes outside of the log. So theta plus 1, there are some intermediate steps. So you just write it down, you will get it. So this will be theta plus 1 times log x1 times x2 times x3 and so on xn. So again, using the property of log. So log AB, you can write it as log A plus log B. So like this, log A, B, C, D and so on, you can write it as log A plus log B plus log C. So using the product rule of logarithm, log AB, you can write it as log A plus log B, property of logarithm. So using that, you can split log x1 plus log x2 plus log xn. So this is log likelihood. So we call it as log likelihood, log of likelihood function. So using this, we are going to differentiate this. in order to get the theta star or the maximum likelihood estimator, best estimator for theta. So you see, so we just let it y be this particular whatever we got it in the previous slide. So what we have to do, we want dy by d theta and equate it to 0. So once I do dy by d theta, I have to do d this particular whole expression divided by d theta. So now I can differentiate partwise. So the first term I can differentiate. So log theta, if I differentiate, log theta will be 1 by theta. So it will be n by theta minus. So now this whole term is a constant, is independent of theta. So now I have only a constant multiplied by theta plus 1 function. So if I differentiate it, I am going to get theta plus 1. If I differentiate, it will be 1. So 1 times log x1 plus log x2 plus and so on log xn. And now what you have to do, you have to equate it to 0. So if I equate it to 0, I am going to get theta will be equal to n divided by log x1 plus log x2 plus and so on log xn. Okay. So this log is log to the base e. Okay. Now your theta star is basically n divided by this log the first sample plus log the second sample and so on log the nth sample. We have 6 samples here, and if you just substitute, we are going to get 6 by log 3 plus log 6 plus log 2 plus log 7 plus log 8 plus log 10. So which will be product of, you just simply take the product. So log 20160, 6 by log 20160. So I just want to know whether this log is base E or
So this is natural log.
not
E.
natural log value only, right? When you take natural log only, it will come to 0.60. Is that correct?
Yes. Otherwise, it is coming 1.39.
Okay. Okay. So the difference comes here. So here in this slide, if you differentiate log theta, if it is base E, you can directly write it as 1 by theta. If it is not log to the base E, if you are considering it as some base 10, so once you differentiate log theta to the base 10, it will be 1 by theta into log 10 base E. Log E base 10, I guess. So some constant will be there. Again, you have to work out with that particular constant, and that will change the value. Okay. So that is why I suggest most of our problems you take the log to the base E only and compute the values accordingly. So yeah, this slide, see, if you are not okay with this x1, x2 to xn throughout the computation, here itself you can substitute the values. So the small x1, x2 and xn, so whatever the values given to us, you simply substitute and deal with only theta. Okay. So you will get, then also you will get. So ultimately we are going to get 0.60. So I have the same kind of problem, but instead of continuous case, I have discrete case here. Okay. So as I said, in discrete case, instead of densities, product of densities, in discrete case, what you have to do? A good guess?
Probability.
Probability.
EMF.
Correct. So you have to product the probabilities, occurrence of this 2 for the first sample, then multiply it with the getting 0 in the second sample, multiply it with 4, multiply it with probability of 3. Get the likelihood function. Then your likelihood function will be in terms of P. Of course, it will be in terms of P because your probability values will be dependent on P. So everything will come out to be in terms of P. And then what you have to do, you have to differentiate it, or you just use right now, most of the cases using log will help for simpler calculations. You take the log of that likelihood function, you differentiate that log likelihood function, equate it to 0, get the value of P. So that will be your best estimate, maximum likelihood estimate of P. Okay. So for this, I will give you some 5 minutes. There are maybe some 28. Okay. Even I will exclude 8 people. At least I need some 20 responses for this particular question. So everyone try to solve it and submit your answers in joinpd.com. The last minute. No, I didn't put the timer. I have my timer with me. Usually in clear deck, I can only time up to 3 minutes. Okay, done. How many of you have written the likelihood function? Some
I've written something.
Okay, maybe I will ask like hand raises. How many of you have written the likelihood function? Okay, only 5, 6, okay, 7. Okay. Others? Okay, 9. Okay. Okay, only 9. Then next, taken the log or didn't took the log? Whatever it is, if you didn't take the log, in this case, you need to work with uv. U times v function. So you'll have two functions with you. So you have to do u v dash plus v u dash. If you have taken log, then that will be much more simple. Okay, let me show you this example also. I have one more maximum likelihood estimate, I guess. Let me see what all answers people gave. The 0.56 or 9/16. So those who have gave, yeah, I think it is correct. Okay. So how do we do is first get the PMF. So the PMF is this 4cx times p power x times 1 minus p whole power 4 minus x. Right? Probability that x is equals to small x. Now the likelihood function, you can write it down as like this. 12 of x1, x2, x3, x4, comma p is equals to product of the probabilities, all 4 probabilities. So each and every probability will be here. So I just wanted to use instead of x1, the value is 2, I guess. So it will be 4c2 times p power 2 times 1 minus p whole power 2. So 4 minus 2, it will be 2. So first thing will be that times 4c is 0. So x2 is 0. 4c is 0 into p power 0 into 1 minus p whole power 4 minus 0. So here 4 minus 0 into 4c, x3 is 4. So 4c4 p power 4 1 minus p whole power 4 minus 4, it will be 0. So it will be 1 times like this. 4c, the last one is 3. 4c3 into p power 3 1 minus p whole power 4 minus 3, which is 1. So now you will get
Last one is 4 power 4c4, no sir?
Is it?
4c3, okay. This one is 4c4, okay.
Okay. So the third one is 4 and the fourth one is 3.
Okay.
So finally what you will get is, see here they have substituted. So what you will get is, if you substitute 2043 and
Finally
simplify,
got a correct answer.
So you will get 24. So for 24 is 4C2 times 4C0 times 4C4 times 4C3, which is 24 times p power 9 times 1 minus p whole power 7. So if you differentiate this, it's fine. If you are not differentiating it directly, if you take log, what happens is, if you take log, it will be right hand side will be log 24 plus 9 times log p plus 7 times, the power will come out of log, so 7 times log 1 minus p. So this is simpler. Now you have to differentiate this function. So if you differentiate it, what will you get? If you differentiate the constant, you will get 0. If you differentiate 9 log p, you are going to get 9 by p. And if you differentiate 7 log 1 minus p, log 1 minus p, it is 1 by 1 minus p into d1 minus p by dp. So it will be minus 1 there. So it will be like 9 by p minus 7 by 1 minus p. The final step is you have to equate it to 0. So if you equate it to 0 and find the value of p, do some cross multiplications, and you will get p to be equal to 9 by 16. 9 by 16 is very much nearer to 0.56. Okay. So there are three main steps. So first thing is to get the likelihood function in terms of the parameter, and also take the log. So the first step is finding the log likelihood. You can treat it like this. So likelihood function, take the log and be there. And the second step is you just take the derivative with respect to the parameter. And once you take the derivative, you equate it to 0 and get the value of the parameter, and which will be, we will call it as maximum likelihood estimator. So these three steps are the crucial steps in this log maximum likelihood estimator method. Okay. Let's go to the fourth one.
So we can directly substitute 2043.
Yeah. So that is what I said. Okay.
Sir, I have a doubt. Like in the lecture, when both the parameters n and p are as given as parameters, not determined, sir has told that np is equal to x bar is the MLE estimator, and then we'll have to solve it, like consider one as constant and then give. So since n is given here, can we simply take p cap is equal to x bar by capital N?
No. That's not the case here.
Okay. Okay, thank you.
Yeah. So only in the case of n and p is not known.
Here we have to estimate only p, right? Oh,
only
okay.
p.
Only
Yeah.
then you can do that.
Yeah. See,
so how do we, sir? How do we get 16?
See here, if you cross multiply, you are going to get 9 minus 9p minus 7p. So this will get cross multiplied. So just do the cross multiplication. So 9 times 1 minus p minus 7 times p. The numerator will be that, and the denominator will not play any role. If the numerator is 0, then we are going to get 0. So equate the numerator to 0. Then we are going to get 9 minus 9p minus 7p, which is 9 minus 16p. You just take 16p to the other side. That will be equal to 16p equals to 9, and then p will be equals to 9 by 16. So just do the cross multiplication.
Okay, sir.
Okay. So now let's go back again to bias variance case. So consider a sample of IID random variables x1 to xn, and here we have given n is greater than 30. Okay, and we have also given you the distribution mean and variance. So each of xi's expectation is given to be equal to mu, and each variance each of xi's variance is given to be sigma square, and there is an estimator mu n hat, which is equal to 1 by n minus 30 times summation I is equals to 31 to n xi. So what this particular mu n hat tells you is, in words, I'm going to consider the sample mean of the samples which are greater than 30. So maybe if I have some 50 samples, if my n is 50, I'm going to consider sample mean of 31 to 50 samples. Okay, there will be some 20 samples, and I'm going to consider that particular sample mean. So that is what this mu n hat states. And what we asked you is find the bias. And those who are done with bias, just try to get the variance and risk also, if interested. Yes, correct, Jivraj. So we can ignore constants. Okay, again recall what bias is. Bias is basically the error between the parameter estimator mu n hat and the mu parameter.
So this will come, answer will come in terms of mu and n, no, sir, or numbers?
So it will be numbers only. Okay. Last minute. Yeah, that is what you should do, Abhishek. So bias is basically expectation of mu and hat. So try to get the expectation of mu and hat. Okay, let us see. So I got okay, decent enough values we got. Okay. Most of you have given 0, correct. So you can also guess the answer, right? We asked you to find the bias and I told you to give the response or maybe even the number. So that is a number which is independent of mu and sigma square, or I didn't give the exact value of n also.
It will come mu minus mu, something like that, no, sir? Actually,
that will become 0.
N minus 30 by n minus 30
into mu minus mu.
Yeah, minus mu. Okay,
So
sir. I
that is
got
what.
up to there, but since mu are coming, then I was not able to go further.
No. Okay, so what I have to do, I have to compute the expectation of mu n hat. Mu n hat is 1 by n minus 30 into summation I is equals to 31 to n. So how many numbers will be there from 31 to n?
Minus 30.
N minus 30.
N minus 30. So there will be x31, x32 and so on xn. Each of the expectations are mu. So there will be n minus 30 mu's.
So 31 is also included, sir.
31 is also included.
Yes, sir. Okay.
So if you are confused that much, what you do is you add 30 values, 1 to 30, and you subtract 30. Okay. Then you can easily observe that there will be n minus 30 of these values will be there. So if you add 30 values to this 31 to n values, you will get n. So that means if you subtract 30, you are going to get 31 to n. So there will be 30 n minus 30 numbers from 31 to n. Okay, that is very easy to observe. So the sum will be expectation of all these n minus 30 mu's. So that will be n minus 30 times mu divided by n minus 30. This and this will get cancelled. And we are going to get expectation of mu n hat as mu. But we asked you for bias. So what is bias? Bias is expectation of mu n hat minus mu. So if you substitute expectation of mu n hat as mu, we are going to get mu minus mu, which is 0. Okay, so that is why I said people who are done with bias, it will be good to compute variance.
Variance is sigma square by n minus 30.
Sigma square by n minus 30. Correct.
And risk is same.
Right. Risk will be same because this is an unbiased estimate. So unbiased means if you got bias as 0, so that particular estimator, this mu n hat, I got bias is 0 for this mu n hat. So I say mu n hat is an unbiased estimator. Okay. So if a question asked you like, is this an unbiased estimator or not? So what you have to do is you have to compute bias for it. Once you compute bias for it, if it is equal to 0, then you conclude it is an unbiased estimator. If it is not equal to 0 and it is something else other than 0, then we say it is a biased estimator. Okay. Okay. So let us do one more problem on maximum likelihood estimate. Suppose it is known that a sample consisting of the values 15, 16, 10, 8, 7, 9, 20, 19 comes from a population with the density function. So now again it is continuous case. So our likelihood function will be the product of densities now. And the density function is given as 1 by theta into e power minus x by theta when x is greater than 0. and 0 otherwise. Okay, so what you have to do is you have to find the maximum likelihood estimate of theta.
Sir, in the last question, if we calculate variance, you said that we'll get sigma square by
N
n
minus
minus
30.
30. So
What did you get?
I didn't get it. I didn't get how we get that.
See, again, do the same thing. Variance of mu n hat. So mu n hat is 1 by n minus 30 times this summation part. So if you pull out 1
Okay,
by
sir.
n minus 30 outside of variance, it will be squared now.
Yeah, okay.
There you will get a denominator n minus 30. Okay, try it out. As they are independent to each other, you can split the variance. You can write variance of x31 plus variance of x32 and so on, variance of xn. So yeah, solve this. I will give some, okay, maybe if 5 minutes is not enough, I will give you 2 more minutes, some 7 or 8 minutes, because this is the last question I have. So take your time, but try to solve it. We have done 2 problems on maximum likelihood already. So by now you know what is step 1, step 2, step 3 to complete this maximum likelihood. So again, I need everyone to
Sir.
solve. Yeah.
Sir, e power x, what is d e power x dx, sir?
d e power x dx is e power x. But d e power some ax, so some constant multiplied by x will be, so okay, I will write it down.
Function of function. That constant will come out, sir. Okay.
That constant will come out, that's it. So it will be a times e power ax.
Yes, sir.
Okay. So yeah, so as I want everyone to solve this problem, I will write down that integration thing. So you have to use this particular formula. So derivative of e power minus x, I will directly give you, will be minus e power minus x. Okay. Or something like divided by theta. If it is there, divided by theta, it will be minus 1 by theta into e power minus x by theta. So if you want to use this, or try to think taking log is helpful or not. So if you try to think that, I will use this particular formula also. Derivative of x power a by dx is a times x power a minus 1. I have taken slant. Okay.
Sir,
Hmm.
sir, natural log of e power a is a, sir.
That is how it should be, right?
Yes, sir.
Okay, do I have to write it down also? So log e power a base e will be a. Okay, use these things. Try to get the final value also. Okay, I'm keeping the screen as it is. So let me know if I have to go back to peer deck slides.
Hello, sir.
Yeah.
Confidence interval and margin of error are important topics.
It's not important. We are not going to ask questions from those topics. But if you are interested, you can go watch those lectures and solve those activity questions also. But we are not going to ask any questions in quizzes or maybe in the end term also.
Okay, sir. Okay.
Okay, that is for your extra content, extra knowledge.
Yes, sir.
Okay, yeah. So people who want these formulas, just write it down. No? I'm just going back to peer deck slides. I got 11 responses. So still there is 3 minutes. Okay, careful. I have given you formulas in terms of with respect to derivative x. But here you have to differentiate with respect to theta and it will change. Okay, be careful with that. Okay, the formulas whichever I gave, there I have taken derivative with respect to x. I just wanted to know how many of you are done. So I can see 12 responses. Okay, Jivraj is done. Sukanya, Deepa, Abhishek, yeah. Viplav, Yash. Okay, Narendran. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 hand raises. Mohan Mohan Raj still doing, no? Prashant,
Also still doing.
Ritvik, Lakshmi, yeah. Ravikant. Okay, people who are trying, at least try it out. Okay, I will give you some extra 2 more minutes, 2 or 3 more minutes. Just try it out. And the other things I wanted to say is, tomorrow there is a revision session, and that revision session is based on week 7 and 8 contents. Okay, and I request everyone to join that session because week 7 is important week.
What time?
So it is from week 8 p.m. to 10 p.m.
Okay.
And on Friday we have mock discussion session again from 8 to 10 p.m. Okay.
Yeah, it's already in the calendar. Yes.
Yeah, it's already in the calendar. See, if you are okay with mock, if you know how to solve every problem in mock, then Friday session you can skip. But tomorrow's session will give you some insights on week 7 and week 8, and that will help you people to prepare for quiz 2. So try at least joining one of these 2 sessions, and I recommend you to join tomorrow's session. Okay. And on Friday we will discuss. I will try to solve each and every problem in the mock, and where I will give you some stepwise procedures for each and every problem in the mock. Okay. So that will help you. Maybe that will help you how to solve some problems in quiz. Okay. Yeah. Okay. Time is up. So let us discuss.
Sir.
You need 1 more minute. Huh? What, Prashant? Prashant?
Yes, sir.
You said sir. Then after what? Okay, why did you stop me? Are you still trying to solve?
Yes, sir. I need 30 seconds.
Okay. Okay. And
Sir,
how is the
please.
preparation? Yeah.
Sir, please extend extra activity deadline, which is on 31st.
That will be extended. Don't worry.
Okay.
It is on 31st, is it?
Yes, sir.
Okay. Okay. We will extend. I will extend. I will ask the team to extend.
Sir,
Okay,
one
sir.
more thing, sir.
Hmm.
Actually, in the grading document is given like 7.5% for the extra activity and 2.5 for the faculty thing. But
Mm-hmm.
7.5, how they are dividing, sir? For every week, 1 mark or something like that, or if you're done 4 and it will be an average. How it is taken actually?
See, if you have submitted all the 6 extra activities with some decent score, we will take the average of the scores and we will give you out of 7.5. We will give you for participation marks also will be there. So few people will not submit all the 6 extra activities, right? So they will submit 3 and then after they will leave. Then what we do is for that 3 we will compute the average, and as you have submitted only 3 extra activities, we will score it for some 5 marks, or maybe we will out of 5, depending upon the marks you got, we'll give you some 3.5 or like. So the completion will gain you some marks, and the scores you get in the each and every extra activity will also be considered.
Okay, sir. Thank you.
Yeah.
Hello.
And all these extra activity bonuses and all this stuff will be 100 plus marks. Okay, so if you are not doing that also, it doesn't mean that you are going to lose your grades. It will only boost your grades.
Sir, and one more thing, in the dashboard, they are showing the average assignment score, which I understand, like they have taken only 8 weeks and they divided it by 10. I think they will add the week 9 assignment, week 10 assignment, and so on.
Yeah.
And in the next line, they are showing average assignment for final scoring. This is just half of the above value, whatever they have given. Like the first one is if it is 74, in the first line it is written that average assignment score for end-term eligibility if it is 74, and in the next line they are writing average assignments for final scoring. It is 37. Like it is exactly half. It is same in all the subjects. They are giving exactly half. But in the graded, in the grading document, I never see where they are taking this 50% half and all. I saw something like 0.1 of grade assignment average.
0.1 of the graded assignment average.
Ah,
Maybe some
I think
glitch. I
it
don't
is.
know.
Sir,
I am also not aware.
I mailed support because I also think that the average assignment calculation, the mark calculation is itself wrong. Because when I was calculating, it was coming 90 something and it is showing 74.
No, what they are doing
So I
is
mailed them
all.
and they said that only they are still updating the thing and then only 6 weeks ka they have updated or something.
Okay.
कुछ हो रहा है पता नहीं.
Okay, but
The score they have calculated like week 1 to 8 divided by 10. Actually, it should be week, best 10 divided by 10, right? Out of
It
all the
should be
12.
no. It's that is for the final calculation, but the eligibility requirement average, right? It should be of 7 out of like the best 7, right? That itself is wrong, and then the final calculation score they're doing half of that. So
Yeah,
if the
final
eligibility,
scoring they are doing half of that.
so
Even I
so
have
some glitches
written.
there because
Yes,
it
sir.
doesn't.
Even I have written to support and they said like it is under progress, but they are not clarifying on what exactly is happening.
maybe that is some glitch. You don't need to worry. Okay. Okay. Prashant, can we discuss?
Sir, can you ask something? Sir, I'm not giving the end term last term, not giving the end term. So this term only giving the end term, or it will be given the quiz 2 also?
No, so you might have got some grade, right? U or I or something. So if you haven't given only end term, you might have got a different grade. So even I am not so either I or U represents the grade that you only failed in end term or you are absent in end term. Okay, in that case you can directly give end term.
Okay, sir,
But if you are
in the
repeating the full course, then you have to
I'm giving
give.
only the end term. Only
Then it is not necessary for you to give quiz.
Okay.
Okay. So is Prashant there? Prashant, yes.
Yes, sir.
Okay. Shall we discuss? Done?
Yes, sir.
Okay. Okay. So I got sorry. In 7 minus 8. See, I told you best guesses. So you should guess in the best possible way. Guessing thing, let's keep it aside as of now. So let us try to go step by step again. So for finding maximum likelihood estimate, we need to get the likelihood function, and the likelihood function is the product of the densities, and the densities function here it is 1 by theta into e power minus xi by theta. Okay. So this will be equal to, so if I take the product of all the, substituting all the values x1 to xn, n products I will have, n terms I will have, and each and every term has 1 by theta. So I will have 1 by theta power n into e power minus x by x1 by theta times e power minus x2 by theta, and so on, e power minus xn by theta. So again, if you are confused, if you don't want to see more variables here, just substitute x1, x2, and so on, whatever the values are given to this. So you will be getting 1 by theta power n into e power minus x1 plus x2 to xn divided by theta. So now people who are interested to differentiate directly, you can differentiate directly, but taking log will help you much more. So if I take log, what happens is 1 will be log e power minus x1 plus x2 to xn divided by theta. So that will be equal to simply whatever the power is there, that will be the value. So that will be minus x1 plus x2 to xn divided by theta, and there is divided by theta power n. If I take log, it will be minus log theta power n. So n comes out of log, so it will be minus n log theta. Okay, now what I have to do, I have to equate it to 0. So sorry, I have just taken log, I have to differentiate this particular function. So if I differentiate, I'm going to get minus n by theta plus, so here if I differentiate 1 by x, so I'm going to get minus 1 by x square. So this will be minus of minus, it will become plus x1 to xn divided by theta square. So now I have differentiated it, I have to equate it to 0. So if I equate it to 0, I'm going to get x1 plus x2 to xn divided by theta square minus n by theta is equals to 0. So you just cross multiply, you are going to get theta will be equal to x1 plus x2 to xn divided by n. So we are going to get the best ML estimator is basically the sample mean. What you have to do, you just have to compute the samples mean. So there are 8 samples given to us, 15, 16, 10, 8, 7, 9, 20 and 19. You just add it, you will get 104 divided by 8, you will be getting 30. Okay, so the best estimate for theta is 30. This is how you have to solve maximum likelihood estimate.
Sir, previous slide, please.
Okay.
This one.
Okay. With this, we will end today's session. And yeah, so try to submit week 9 assignment as early as possible. Try to do it by today or tomorrow morning, because tomorrow evening you are having the revision session. So from tomorrow afternoon, you just focus on quiz 2. Okay, so that is how you should be. So if you have to focus on quiz 2 tomorrow, you have to submit week 9 today or tomorrow morning. So make some time, submit the assignment, and then move to weeks 5 to 8. Okay.
Sir, what
Hello,
is the
sir.
weightage for week 1 to 4 in quiz 2?
See, that we will give you. Hardly there will be 1 or 2 questions. So some 10%, 10 to 15%.
Okay.
Okay. So the weightage part we will provide you.
Sir, how to approach for 1 to 4 revision for each every just if we revise the notes, it will be enough.
Yeah, it will be enough. And the questions are also will not be that difficult. Okay. And
Okay,
also our TS have taken
yes, sir.
the revision
Yesterday.
session yesterday. Yeah, right. So just go through that session.
Okay, sir. Thank you, sir.
Okay, yeah.
Sir.
So thanks.
Hello.
Yeah, thank you, sir. That session was very helpful.
Yeah. Thanks a lot, and have a good day.
Hello, sir.
Yeah.
In graded assignment number 9, last question is of 0 points. Why
See,
is
there
that?
is some error in that particular problem, so we just don't
Okay,
wanted
sir,
to
okay.
grade it. Okay.
Okay,
Yeah.
sir.
Sir.
Thank you.
Sir. Sir, while finding maximum of L, sir, the maximum likelihood,